Hey guys, welcome back to my YouTube channel. So in my previous video I spoke about the interface as well as the polymorphisms. So in this video let's see about the trading concept, so how the trade works, and we'll be seeing the Java collections things. So all the collections are there inside the Java, so set linked list, array list, as well as the hashing map, all those things. So now you can just access the particular playlist. The link will be mentioned below. So here the fourth video will be also uploaded, so because I am recording after recording the fourth video right now, so you can just access the 5 videos of this playlist for your better interview experience. So once if you have seen these all 5 videos and neatly, if you have concentrated 100%, you will be cracking the particular interview. Let it be any interview for the full stack or a Java or any developer field interviews for this particular current domain name inside the top MNC companies or startup companies. So let's see with the concepts right now. So the concept here in this video is, as I said, the trading. So the trading is the concept which I am just trying to tell you. So then coming back to the concept, so what is trading? Trading is something like, trade is one, we call it as a process over here. Suppose in your home, your mom or dad might say you the n number of works, like so mom might say you to get meat, get the particular groceries, get the particular vegetables, and get the particular anything like bread, bun, something like that. So these all the process. So inside one particular so that entire is one particular trade. So these all the small process you have to do it. So at that time, if you just go for to bread, you will first go to take the meat, and you will go to take the bread bun, and you'll go to get the groceries, and you go to get the vegetables and get the particular fruits. So one thing, there are two things you can just notice over here. So one thing you can go, so you can just go to the meat shop and you can just tell I want 1 kg chicken. So there might be a number of people to be so as you go, they won't give you, right? So it takes little time. So that one thing, you can just go there and you can wait for 10-15 minutes and you can collect the meat. Then you'll go to vegetables, then you will buy all the things and you'll go to the next process. So step by step you will be doing. So this step by step things going to take a lot of time, and it might consume a lot of time. Like one particular thing is done, so again you are going to second, then again you are going to third one, again you are going to the fourth one, at last you will go to the bring vegetables or fruits. So everything will happen step by step. So it is not a entire process, it is entire process, but it is going to take a lot of time. So same thing you can do one more second option is, so you'll go to the meat shop, you'll tell I want 1 kg chicken. Then as soon you give the order, you'll go to the vegetables. As you give the orders, you'll go to the fruit shop. As you give the orders, you'll go to the grocery shops. So you have just done what? You have just went to the first process, second, third, as well as the fourth. You have just given the instructions. So the things is going to happen inside your bracket. So at the time you are going to grocery shops, the meat, the particular meat would have done the particular, you have cut the pieces and you would have packed and you have kept ready for you. And as well as for the groceries also, as well as for the fruits also, as well as for the vegetables also. So just you'll order for in all the 4 places, and we'll just tell I'll come in some time, you please keep ready and come, like that. So in here, what is the thing happen here? You can consume the time over here. So it is just less consuming time rather than the previous option. So you'll just order all the 4 places, then again you'll come back to the first. So you'll just collect the output from the vegetables, collect the particular grocery from the grocery shop, collect the particular fruit from the fruit shops, and you'll come back home. So this is the second option, you can do it. So this entire second option, what I have said, that is nothing but a trade. Okay, so it is a very simple example I have just explained. You can see trade is a shared memory area. So it will just share, it uses a shared memory area, and it is a faster content switching. It is just a normal, compared to the normal process, it is very faster. And light trade is a trade is a lightweight, where the process is a heavyweight. So process might be heavyweight, trade will be the lightweight. Suppose you are taking a grocery, it is a process is a very heavy. Trade is something like you are just going and ordering the particular thing, you are just calling the functions. So here you see we have the process over here, process 1, process 2, process 3, and we have the trade, and it is also one entirely, it is a process. So this thing, it is one example. Let me say with the example with the programming way. So in the programming way, let's see. So flow control of the Java. So without Java trade, so just simply example, what is the flow control of the Java? So without trading, so main function, suppose I am just calling the main function, like may have function 1 and I'll be having a function 2. So main function is going to call, first it will call the function 1, it will complete the task, then it will call the function 2, it is going to complete the task, then program is going to end. So it is what the normal flow structure of the program over here. If I just show you with the object over into program 2. So here you have we are having it two classes over here. It will just call this one, and it will just set the properties. Again, it is going to run this particular line of code, and it is going to run this line of code. So step by step program will be happen. That is what step by step process is going to happen. But with threading how it happens means, suppose I'm calling the main function, it will just call the function 1 and function 2 fastly. It will just call randomly function 1 as well as function 2. So which are according to the process, the function is going to end. So but the two functions also get called, but one by one. So it will just call and it will just end it. So now automatic the output is going to print like that. Okay, here step by step is happening, but here at that time your main function is going to run. So you will call the function 2, you will call the function 1 as well as the function 2. So it is not going to wait for the output. It is suddenly it will just call the functions, and output is going to print after that, after the completion of the task. So here you are, which is the process of threading over here. Okay, so here we can create the thread. So we have the creating a thread by using a two ways. So one is by extending the thread class. So we can just create a thread by using extending the thread class. And by implementing the runnable interface. So with these two things, I can just, so they might ask, how can you create a thread? By extending the thread class and by implementing the runnable interface. So with these two things, you can just create the particular thread class as well as a runnable interface. By using this one, you can just create a thread. So steps to create a Java thread using runnable interface. So using a runnable interface, how I can create the particular thread? So we are creating a class implements the runnable interface using the implements keyword. So let me open one example. The thread example is might here itself somewhere. So here is the thread. Okay. So here is the thread. So this is a thread. Yeah, this is a thread. So what we are doing here is so we are having the my thread. So we are using extend. So how to create a using extend we'll see. So or else the thread class and the thread. So by using a runnable interface is here. So normal thread, my thread is here. So let me see this one. Okay. So it is just a normal thread. So in the thread also a number of ways are there. So just I'll explain one example. So let's first see this one. We can create and implement the runnable interface by using implements keyword. So we can use a runnable class, override the particular run method. We need to override the run method, then create an object for the implementing class in the main method. We can just create the object for it and instantiate the thread class and pass the objects to the thread constructor. So whatever the objects we have been created in the main method, we need to just pass to the thread constructor, then call the start method as well as thread start going to call the run method. So whenever I'm calling the start method on the thread, the start method will call the run method. So, okay, so start and the run method is going to call. So it is what the things work. So that is how the things works. So runnable interface versus the extending the thread class. So since we discussed both, we have created a thread Java, you might question in your mind that how the that should we use runnable interface or a thread class. So this is an obvious question in method in Java. Let me answer this question. The runnable interface is preferred over extending the thread class. So whatever the thread classes will be that will be preferred by the runnable interface. Okay, because of the following reasons: as multiple inheritance is not supported in Java. Okay, and the thread class, if your class had already extended some of the classes, so this is one thing. And while implementing the runnable, we do not modify or change the thread behavior. We cannot modify the behavior of the thread when the program and the process is going to execute it under the runnable interface. More memory is required for the extending thread because each thread creates a unique object. So when you are using an extend keyword at a time, it take the more time because the classes will going to deal with the objects, which take the time. Less memory is required when implementing the runnable interface. So when we are using with the runnable interface, at that time less memory is going to take and thread will having the same objects over here. So that the life cycle of a thread over here. So this is the life cycle of here. So new, runnable, running, and terminated, and non-runnable block. This is a very simple example. So whenever I start the thread, whenever see thread, we need to use that keyword that is thread to create a thread. So thread t1 is equal to new thread. We have initialized that thread. So we have been new. So whenever what is new is going to do here is it will just start the particular thread over here. T1 dot start is going to run and it will go to the runnable phase. So in the runnable phase, thread pick by the thread scheduler. So in the runnable, what is going to happen means, so thread is going to pick the particular process according to its time. It will be having a time scheduler. So whenever runnable is happen, run method is going to run. So it will run the particular thread now. So at the runnable state, it will take the particular, it will select the particular thread and it is going to run. So again, it will just goes in the sleep mode. Again, it will just go a bit. Again, it will come. So all the thread is going to pick. So time scheduler, thread scheduler is going to pick the particular process and it is going to run. So as it's run, then what it does means the particular process which is been run, that is going to that will be going into the sleep mode. That goes to the sleep mode. That means once it is been done, again I don't want to print the same stuff, right? So it is going to in the sleep mode. Then again it will wait to pick. Again it will wait so that the thread should be pick another so the thread scheduler should pick another process. Again, once it has been picked, it will run. Again, it will keep that particular thing into the sleep mode. Again, it will wait to same thing. So when all the things is been done, so after the sleep and after the particular thread is picked and it goes to the sleep mode, that particular thread is going to block. That particular thread is going to block. Again, it is not going to run the particular process only one time, right? If I say you to bring the meat, groceries and vegetables and food, only one time you will just call that all the 4 things. You are not going 100 times, right? You are not going to call the fruit don't go to the fruit shop and bring a number of friends. One time you will bring and you will come back to the home, like that. So but you might just will call it again, will go, but you will just check the output of it. So that thing, it will be in the sleep mode. We'll just go sleep mode and you will wait for it again to get the output of it. So once it is been done, the thread is going to block, like that. The things will run. After all the things execution done, the thread is going to terminate it, like that. Okay, so you will be, this is how the very simple I have been explained you guys. So you can see the new is instance the thread which is not yet started. So it is not yet started, it is just start things will happen. In this state, the thread is also is known as a born thread. At this stage, the thread is a newborn state. Okay, before the start is one. So runnable, what is at the runnable? What happens means, after invocation of the start variable, whenever the thread is getting started, before it is selected to run by the scheduler, so it is will start, and the thread scheduler before selected with the thread scheduler, it is just a previous thread of this, that is runnable. Running is means after the thread scheduler has selected it. So when the particular thread scheduler is picked the particular process, at that time running is going to work. And non-runnable thread means, so what is non-runnable here? Non-runnable means thread is alive, not eligible to run. Thread is alive means the thread they have selected, it is going to start it. So it might give the result after some time, like that, but it is blocked. So as it is blocked, but it is not going to execute again. So it is not eligible to run again. And terminated means run method has been exited. So after terminated, the run method has exited. That is the thing will happen. So it is all about the threads. So this is all about the theory part of the thread. Now I will introduce with the particular examples over here. So let's introduce with this simple example. I'll just run this particular thread. So here, see, when I run the program, what is the output I'm getting? See, I'm getting a number of things. I'm getting running thread, thread happy, running thread, happy thread, running the thread happy, running, same as this I'm getting. So then at the last I'm getting thread two running thread, 2 red happy, 2 running thread, 2 red happy. So like this, it is just running the particular process. What is happening here? See, so as I said, so if I want to create a thread for the class my thread, I'm just using a class my thread, extend the thread. So what is thread here? So thread is something like, as you know, we are using a thread as using extendable. Okay, how we can create the thread? By using extendable class, and I can just choose second by using a runnable interface. So it is using the extendable class. So I am just creating one thread class by using a thread method. So here, as you know, whenever I am creating a thread method as using extend class, I need to invoke a run method over here. So it is what I am just using, and we need to override it. So we have override it and we have used a run method. What it is going to do here is, here something is there. So what I am running one while loop. So I is equal to 1, I is equal to less than 10. So until it should run 10 times. So running the thread as happy thread, and it should increment the particular I++. So overall 10 times it should, I think, yeah, 10 times it should work. But in the run method, what it does means, according to its time scheduler, it is going to pick whether I need to pick this one, either I need to pick this one. So 10 times it is going to call. And second, again I am just creating my thread one, and that is also extendable thread. So here, so this is where 2 thread we are creating it. One is the my thread and one more is the my thread one. So what it does means, in the my thread one, so public class variable. So here also we are just applying the while loop. Here one thread is running. So thread, so I'll just tell thread 1 is running. Okay, sorry, I'll just tell thread 1 is running. Okay, so here I'll just tell happy thread 1. Okay, I'll just tell HAPPY happy thread 1. I'll just tell happy thread 1. So happy thread 1 I'm just telling like this. Okay, so here I'll just tell thread running thread, I'll just tell running thread sorry, I'll just tell here as a running thread 0, and here I'll just tell my happy thread 0. So I'll just tell it. So I'll just save the program. So here what it is going to print means, it will, we have, once we when we have the 2 thread which has been extended using this one, we have given some of the process to run, that while loop should run. So it should run this much. So at the time it should run like that. So at 10 9 8 7 it will run, and it will just increment it until this condition is satisfied. It will just going to run like this. Okay, so here what we have the 2 thread. Now here what I'm doing here is, so now I'm creating a thread now. So I'll just tell whatever I'm just creating an object for the thread, my thread 1 as well as a my thread 2. So here my thread 1 and my thread 2, right? So where is the my thread here? Okay, we have 3 things here. We have the thread, my thread, and my thread 1, and here we have the my thread 2 also. We have the 3 things over here. So thread 2, I'll just tell here 2 running thread, 2 running thread, so 1, and here is 0 0 1 and 2. So we have the 3 threads, which is using, we have extended the thread keyword, and we have implemented the run method in all the threads. So when it has been done, now I'm creating it 3 objects for it. So now I'm just telling t1 dot start, t dot start, t1 dot start, as well as the t2 dot start. That means t0, I'll just make it here t0 dot start, and t0 1 dot start, and t1 dot start, t2 dot start. So now see, I need to get the output. So let me see which is the output I am going to like which all the outputs I'll get. So 0 1 as well as a 2 we have. So I'll just save everything, I'll just save all. So now I'll just run this method. Now I'll just run the particular program. So now see, according to the thread cycle, thread scheduler, it is going to pick the particular process, and it is going to print. So you can see I'm getting in this version. So you see, all the 3 things is getting called, over here, but the process is running inside the foreground. So you can see running thread 0, happy thread 0, running thread 0, happy thread 0, and running happy, and then same it has been till here. So now thread 1 is running, my thread happy 1, thread 1 is running, thread happy 1. So all the thread is running, and second one is running at the last. So like this, the thread scheduler has the pick the particular job. So okay, so once it has been done, so it has been so like this, I'll just tell SOUT also out. I'll just tell 0 done. I'll just tell 0 done. Okay, so I'll just tell 0 done. I'll just write here as a 1 is done. So once it has been done, the process should done. It should just print 1 is done. Then again it should print the 2 is done. Okay, 2 done. So I'll just tell 2 done. I'll just save it. Now I'll run the program. So now let's say, so as basically the thread is we have been implemented using extendable keywords. Then we are just doing like this. So now see how the things works here. So see, 0 done, 1 done, 2 done. Now you got the right. See here what happens means, whenever the process, it will just call the process, it will print here. It will just call the process, it will print there. It will just call the process, it will just print in. And then in the background it is going to see it over here. So where is the output? It is I'll just again see, once it is just, it will just call, and it is, see here I am getting here. So first it is just telling 0 done, 1 done, 2 done. That means first it is going to print all the things. It will just call, it is the thread process started calling the particular class. It will just t0 dot call, it will just go to this one, and it will just call this particular class. It will just call this particular while loop, all this run method it is going to call. It will just call, and it will come back, and the process will go in the back. It will just call, and it goes to the wait mode, and it will block it. Then it is going to print this one. Again same thing happens for the thread 1, and it will thread 2 also. It will call, it will go into the sleep mode, again it will come back, and then the next line will be get executed. So 3 lines is get executed. Then after giving the result, after my thread 0, so now here my thread 0 is giving the result first. So the thread 0 result is going to print here. You can see all the thread 0 has been written, giving the result. Then thread 1 is giving the result, so you can see. So then thread 2 is going to be giving the result. So again you see, happy thread 0, happy thread 0, happy thread 0. That means how it happens means, which it is our job, it is not our job to select the process. It is the thread scheduler. The thread is going to pick which is the particular which thread is going to give output soon. That is going to pick, that is going to pick the particular output of it, and it is just going to print it like that. You can see, so it is happening everything inside the background. So according to the time scheduler, I am getting an output over here. So it is, but first I called the thread 0, but it is going to print at the last, because it is going to print at the starting also, but only 9 time has been taken, and the remaining one is printed at the last. You can see, so it is not happen same time every time. So now it might be for an again now right now it is might come at the starting. Note, see, it is not there. Okay, it is the time scheduler, thread scheduler work which is going to take in there into that particular priority. Okay, so it is what about the thread extendable class. So next, coming back to the one more example, thread 2. So let's tell thread 2. So it is using a runnable interface. So this is using a runnable interface. So what is runnable interface here? Same thing. So here, but I'm extend. So in the starting we'll be using a keyword that is extend threads. So here I'm using a implement runnable. We are using the keyword that is implement, and that is runnable. So it is using a runnable. So we are using a keyword that is runnable, and others implementing the runnable. That was the extend thread. This was the implement this was the implements runnable. So we are having a 2 thread here, runnable 1, runnable 2. So we are having a 2 thread. So what we are having here is, so we have a thread 1 and we have the thread 2. So same way I'm just creating the my thread 1 and just creating the 2 objects. And okay, so what is done here is my thread 1 m1 is equal to new my thread 1. Okay, my thread 1 is done. So then again thread t1 is equal to new thread. So thread t1 is what? There is no t1 here. Okay, so okay, my thread is so t1, so t1 dot start and t2 dot start. So new thread. Okay, so what we need to do here is when we are using a runnable interface, we need to call a thread also. So as we have said in the, as we have read in the note, so what is that here is see, initiate a thread class and pass the object to the thread constructor. So we are creating the object of the implemented class. So what are the implemented runnable class we have been created, that we daughter the object is there, we need to pass inside the thread constructor. So this is meaning is nothing but this one. So we have created a particular m1 is a my runnable interface object, then that m1 I am just passing into the thread. Again m2 is being implemented and m2 is we are just passing into the thread. So then if I just tell t1 dot start as well as the t2 dot start, if I run the particular program, so now see, so let me see what is the output I am going to see. So it is just printing the right. Let's right click and run the particular program, this one. So here you see thread 1 is being called and thread 2 is been getting called. So here see 1 1 1 1 1 and 2 2 2, all the 2 threads is been going to print. Just I have been using the s4ut, you can just apply the while loop also, like that also you can, it works. If I just tell s4ut out, so let's tell t1 is done, t1 is done, and I will just tell at the last I'll just tell here as a t2 is done. Let's tell t2 is done. So if I run the program, see here, it will be same how we got in the runnable interface, same way we will be getting here also. So you will see in the output, so you can see starting is only done, t1 is done, t2 is done. Just it just started the particular thread and it is just going to print like this. So you can see like this is going to print. So I'd like this the things is going to work. Okay, it is according to the thread scheduler. The concept is same, just the syntax is different. So we can use whichever you like, runnable or extending thread. So runnable is going to save your time as well as the memory. So it is what the thing is that we need to pass inside the thread over here, whatever the object of the runnable interface you have been using it. Okay, so this is all about the threading concept. So it is more than enough for the interview purpose, and I have explained the entire concept of the threading over here the very briefly. Okay, so now this is all about the threading thing. So now coming back to the next concept, Java we have just saw everything. Now coming back to the concepts of collections framework. So collections I'm not going to explain with the programming part. You can just I'll just all things is written in these notes itself. So why we want collection? What is the collections? A collections represents a group of objects. In the Java, collections provide the classes and interface for us to able to write the code, interface us to able to write the quickly as well as efficiently. So why we are going to concepts of frameworks here of the collection framework here is in Java we have the classes. We have the classes in Java and interfaces for us to able to write code interface. For us to able to write code in quickly and efficiently. So with using a collection framework, we can write the code quickly as well as it will be very efficient. Why do we need collections? We need collection for efficient storage. So as for the efficiency and for the better manipulation of the data in the Java. So manipulation of the data, better manipulation of the data. So we are having an array, all those things. Now I will tell you the way we are going with the collection framework. With the topics we'll understand this one. See, suppose we are having an array. So why we need a linked list, when we need a array list, all those things. So in the array, so we can see when we are using an array, we want to resize up. We use array to store integers, right? And anything. But if you want to resize the array, we can't do it. Insert the element in the between, I can't do it, just the normal array. Deleting the element in the array, not possible. Applying certain operation to this array, not possible. So we are going to the concepts of array list. Okay, so that is array list comes under where the collections hierarchy in Java. So these are all the collections in Java. So collections in Java are available in the classes and interfaces. So what all the collections is there, that particular code is been there where inside the interface as well as the classes of the java.util. Okay, following few commonly used in Java. So these are all the collections of Java: array list, set, and stack, as well as the hash map. So what is array list? So for the variable to resize a particular collection. So in the normal array we cannot resize and we cannot push pop operations cannot be done with a normal array, but using array list arrays we can for variable size collection. So variable size, suppose I want to push we need to perform a few of the operations, few of the methods with array list, I can just do it over here. And sets, so for the distinct collection, for the unique. And stack is for the last in paired first out data structures. And hash map for the strong value key and pairs. So these all the collections in Java. So collections in Java will be everything, as I said, it will be there in the package, that is java.util.arraylist. okay, it will be there inside here. And java.util.set, it will be coming all the properties of set. In the array list all we have like this. So import java.util.treesets also we have. So here array list in Java demo and method, let's see. So the array list class is a dynamically array found in Java. So as you know, so the size of the normal array, as I said, the size of a normal array cannot be changed, but array list provides us the ability to increase or decrease the particular size. So as I said, so the array list then standard array, but it is a slower than the standard array. So array list will be the slower than the standard array, but it helps us to manipulate the data very easily. It can be done. Okay, so how we can declare, this is the syntax. So just we are telling array list, here we'll pass the integer, here L1 is the object of it, and we are just telling new array list. Okay, so we are getting L1 object for the new array list with this particular syntax. So this will create a array list object of the integer type, that is L1. okay, so this is the syntax. So performing the operation, now we have created an operation L1. Now we have created with this directly. Now if I directly add the values to it, see, array list comes with a number of the method that can use manipulate the data. And see, I will have it add method, I can have the add objects, add index at the indexing position, I can add the particular objects. We are like this. So see, like this, suppose we are having a public this is the particular public. Okay, we have this thing. So we have just declared L1 array list from the Java. So if I just tell import java.util.store, all list, array list side, everything is going to come inside this. So here you see L1.add1, add2, add3, add4, add 5, 5. That means insert the 5 value with the 5th index position over here in the L1 array. So I can just print the L1, means I can see 1, 2, 3, 4, 5, 6. I'll get the output over here. So output has been not printed. So output I can just print in this particular fashion. So I can just do add operation, push operation, pop operation, all these things. You can just do it over here. So I can just Google it, what are the array list methods, you can just find it over there. Now next coming on to the linked list. So now, so this we can done at the ending, and you can just use the inserting position at the 5th position, and all these things. Suppose I want to access the particular accessing the particular element from the middle, and I want to know the particular previous address of the element, and for the things. So for that I cannot do it with the array list. So that I can achieve using a linked list in the Java. So the linked list is a Java provides using a doubly linked list. We have singly linked, doubly linked list. So each element of the linked list is called as a node. So here each element is going to act as a node. Each element, each particular array size is going to act as a node 1. So it is a node 1, node 2, node 3, like that. Okay, each node points to the address of the next node and previous node. So this is one node. So this has the address of the previous node, and this node has the address of the next node also. So in the linked list, the first node will be act as a head, and the last node is going to act as a tail, and each one will be having a null values over here. It will be having one null value at the last. So but the middle nodes will be having the address of the previous node, and the at the last node, and it will be having the address of the next node also, previous node as well as the next node. So this is all the concepts of linked list. So the linked list are preferred over the array. So we will be preferring the linked list over the array because the insertion and deletion in the linked list can be done in constant time. So even we can do in the arrays also, array list also, but it is going to take little bit time consuming. So time complexity will be more there. But here we can done in the constant time over here. But in array, if we want to add or delete an element in between, then we need to shift all the other element. So if we want to delete any element, we need to first shift it, then it is going to delete. But in the linked list, it is impossible to direct access the element. If we want to traverse the whole linked list, we need to traverse the whole linked list to get the desired element. So that means we are having a previous and as well as the next node address in the linked list. So easily we can delete the particular item, we can access the particular item in the linked list. That is what it has been said. We can just traverse the linked list, and I can just get a particular previous node as well as next node, then I can get the particular values of it. Okay, so array list versus linked list. Although array list and linked list both implement the list interface, so array list as well as the linked list, it will use the list interface itself and have same method. It is important to understand when we use which one, we to use at what time. So the insertion and deletion can be done in the constant time in the linked list, that is 9. So it is best to use linked list when you need to add or remove the element frequently. So if you want to add the element and remove the element, at that time I can go ahead with the linked list. Use array list when you want to access the random element frequently. If I want to access the random element frequently, it can be done in the linked in the array list in the very constant time. So performing the various operation in the linked list. So we have seen in the array list, so what all the add operation was there. So similar to the add operation is there inside the linked list also, and add index. So same operations we have inside the linked list. So the only thing is here is we'll be using as array list is going to rewritten as linked list. Here also new linked list. So L1 is the object created for the linked list. So we are using add 1, 11, 12, 13 and add at the 5th position 77. I can just access all the element. You can see 11, 27, 45, 77 as well as the 77 is going to print. So this is why the thing has been done. So it is all a linked list over there, and we have a number of method and operations of it. So what is the hashing in Java? So that is all about the array list as well as the linked list. So hashing in Java, they might ask what is hashing in Java. So hashing is a technique to convert the range of the key value pair to a range of indices. In hashing, we use hash functions to map key and some value pairs. So the hashing is basically a key value pair. Okay, just say to the interviewer, it is a key value pair, and it has it has the hash functions to map the keys and some of the values to it. So example, we have the array. We'll see array is equal to 11, 32, 22 and 34. Suppose if I want to find the index of it, what they are going to do here is, so they will be like hash index is equal to, they'll give the indexing as well as the key value pair, right? So for there will be percentage with the 10 value, and for the 11 there whatever the value will be there 1, for 33 3, for 22 2, for the 14 4 is will be the indexing value of it. Okay, so here you see for the key value pair, so in the hash table how it stores, see, so for the 11 it is a key. No, they are giving no using a hash function, they are using a hash function now. So 11 percentage 10 is equal to 1. So at the hash table at the 0th position or the table of the 0th one, the 11 is going to store. Okay, so at the 0th one the 11 is going to store. And next table, so we have a key, hash function and hash table in the hashing. So in the 33 percentage 10 is equal to 03. So the remainder is 3. So 3 is going to store with 3 is going to block the element that is 3. So at the 3 hashing table the 33 is going to store, and 22, so it will just store here no 14. So 1 4 is a 4, at the 4th position it is going to print it is going to store the particular element. So collision, the hash function map to key value pair in the single index, such a situation known as a collision. Suppose again if I try to add 24, the percentage 10 will be a 4 itself, but 4th position is already been placed. At that time the collision occurs. So suppose you can see if I just we have 22, 42, 64, 71. So at the 22 as well as the 42, at the time of 42 the collision is going to occur. So at that time, now what happens? At that time the collision occurs, right? At that time what happens means we have the key 71. See, this is example. So 71 here is a 71 percentage 10, 1 is going at the 1, the 71 is going to store, 22 at the 2 22 is going to store. Now 42 again the collision is happening here. So what it happens means 2 is going to store after the first 2 is going to in this particular hashing table. So 2 is the hashing table values for the 22 as well as the 42, and 64 is going to store at the 4th position. So in the above image you can see 22 and 44 are mapped to the indexing number, that is 2, that is a hash table. Therefore we need avoid to collision. Following techniques are used to avoid the particular collision. So another technique they are using to provide the particular collision in hashing. So we have a open addressing as well as a chaining. So they are using a open addressing as well as a chaining concept to just get rid of the collision over here. So this is more than enough. So your interviewer will be very much happy. So if you explain this with this example, okay. So just we are having a key value pair. So this is a key and they are having a key function value. So it will just pair with the hash table. That's it. Okay. Next, hash sets in Java. So hash sets class is a hash table for storing the element. It implements a set interface. Duplicate values are not allowed. Only the duplicate values are not allowed in the sets. Before storing any objects in the hash code, and equals method to check any duplicate entries in the hash table. So see, so avoiding this one, they are having a open addressing and chaining. So one of the hash sets in Java is there. So in the hash sets, that is what it is just saying. Before storing any object inside the hash set, use the hash code. They will be using a hash code and equals methods to check any duplicate entry is present in the hash table or not. Allows the null value. It will allow the null value. Best suits for the search operation. So hash set is used best for the search operations. So constructors of hash sets, we have hash sets. We have these all the constructors of the hash set. So hash set is a constructor it can just store the 16 element and has a load factor of 0.75 and has initial capacity, and we can set the particular has set constructor used to create new empty sets with capacity and load factor. So with just initial capacity we can add, this is the initial capacity with the load factor, and this is the ternary operator. And the constructor is used to create a hash set using the element of the collection. So these are all the very advanced topics, so let's leave it at one. So see here, for the hash set they are just using the hash set, so we are declaring the particular 16 is what 16 is the initial capacity of it, and the load factor they are using is 0.5. okay, so there you can see 1 2 3 4, so all the values is being stored. This element is ignored. Why? Because 6 8 and 3 11 this element is getting ignored. So why it is getting ignored means 8 3 11 6, so 8 3 11 6. So why it is getting ignored means because already the 11 value is been present, so it is going to ignore. So the duplicate, to avoid the duplicate element, hash set is been used over here. So that is what the complete object oriented programming, and we have seen a lot of complete, I can say that you have seen complete like almost the core Java concepts. The advanced Java as well as the core Java concepts I have been taught you in this entire playlist. Okay, so this is all the questions is going to arise from the interviews. So apart from this, there is not any question they might arise. So we have seen entire object oriented programming, and we have saw the collections of the Java, not in that, but we have taught you in that particular sense, like you can able to access with your interviewer like entire what all topics is there, like what is exactly the hash maps and sets, linked list, array list is going to work. Okay, so this is all about the things. So you can, along with this, you can just run with the same string. We have string buffers, we have, you can learn, you can just glance the string buffer also. So along with this, I can just say you another thing, they might ask you the another like what is the software development life cycle, how you can just use that one. And if you are going for the specialist programmer interview, so along with this knowledge you need to have the data structure knowledge, so the stack, queue, and all the like a number of, like we have the greedy method, and we have a number of methods in the data structure concept. You need to be aware of the data structure concepts if you are going to the specialist programmer interviews. So if you want to access with the startup companies normally interview which is going from the college side, so you need to have this kind of this all the knowledge of the Java. So these same things they're inside other but in the Java we have collections, but in Python we don't have any collections like that. So we have object oriented programming, we have the advanced frameworks like Flask and all those things. These are all the technical interviews might arise from your interviewer. So I tried my best to explain all the concepts with the programming examples, with the live examples we have been saw, and I have provided you the notes also, so you can just copy, you can just download this note from my description below. And if you are new to the channel, please subscribe to my channel, and I will see you next time. Take care, bye bye.